Your conscious mind did not decide to make your heart hammer in your chest when you saw that harmless house spider or stepped into that crowded elevator. Your brain made that call roughly 200 milliseconds before your thinking mind even registered what you were looking at. You are walking through life carrying an ancient biological tripwire that deliberately hijacks your sanity for threats that do not exist. That sudden surge of panic is not a personal failure, and it is not a character flaw. It is a hyper-specialized neurological shortcut that prioritizes your survival over your objective reality. Today, you are going to understand the exact wiring behind why your nervous system manufactures pure dread out of thin air. We are decoding the subcortical bypass mechanism, the low road of fear, and the counterintuitive behavioral trap that tricks your brain into turning minor, everyday triggers into full-blown phobias. Think about what actually happens inside your skull the moment you feel sudden, irrational fear. You are walking down a quiet trail or reaching into a dark cupboard. Out of the corner of your eye, you catch a glimpse of a coiled, dark shape. Before you can even formulate the word snake, your body explodes into action. Your pupils dilate, your breath catches, your muscles flood with glucose, and you jump 3 feet backward. A fraction of a second later, you look closer. It is just a coiled garden hose. Why did your body react before your eyes even knew the truth? In 1996, neuroscientist Joseph Ledoux published groundbreaking research that completely redefined our understanding of emotional processing. What Ledoux uncovered was that sensory information entering your brain takes 2 completely different pathways at the exact same moment. When your sensory organs detect an input, that raw data travels immediately to the thalamus, which acts like the central relay station of your entire brain. From the thalamus, you would expect the information to go straight to your visual or auditory cortex, so your thinking mind can analyze what is happening. That pathway exists, and Ledoux termed it the high road. The high road travels from the thalamus to the neocortex, where your brain carefully analyzes shape, texture, color, and context before sending an informed assessment down to your amygdala, the almond-shaped threat detector deep within your temporal lobe. The problem? The high road is slow. It takes roughly 300 to 500 milliseconds for that high-resolution conscious analysis to occur. In evolutionary terms, 300 milliseconds is the difference between dodging a predator or becoming lunch. So your brain has a secondary emergency circuit, the low road. The low road bypasses your conscious visual cortex entirely. It sends a crude, blurry, low-resolution signal straight from the thalamus directly into the amygdala in less than 12 milliseconds. Your amygdala receives what is essentially an out-of-focus snapshot. It does not know if that shape is a venomous viper or a harmless piece of rubber. But your amygdala does not care about accuracy. It cares entirely about speed. It triggers the autonomic nervous system, dumps adrenaline into your bloodstream, accelerates your heart rate, and forces a motor response before your conscious cortex has even processed the first frame of high-definition video. Think of it like a smoke detector in your kitchen. A smoke detector is not designed to tell you the difference between a 3-alarm house fire and a piece of burnt sourdough toast. It is engineered with a hypersensitive threshold because the cost of a false alarm is a momentary annoyance, while the cost of a missed fire is catastrophe. Your brain is running that exact same calculation every single hour of your life. If you think about the sheer beauty of this biological machinery, it makes you realize how much of our everyday suffering is simply ancient code running in a modern world. By the way, if uncovering these hidden neural loops is giving you clarity on how your own mind operates, take a second right now to leave a comment with your thoughts and subscribe. When you interact with this science, it signals the algorithm that deep human neuroscience actually matters, which helps us continue uncovering the real mechanics driving our daily behavior. Now, back inside that neurological circuit, this smoke detector principle creates a profound behavioral consequence that most people completely misunderstand. Because once that alarm goes off, your reaction dictates whether that fear pathway becomes a temporary glitch or a permanent neural superhighway. Here is the revelation that turns everything we assume about fear on its head. When your alarm fires over something objectively harmless, a tiny beetle on the wall, an awkward social silence, an enclosed room, or the physical sensation of a skipped heartbeat, what is your immediate instinctual reaction? You escape. You step away, you leave the room, you check your pulse, you avert your eyes, or you distract yourself. And the moment you pull back, what happens inside your body? You feel an immediate, sweet wave of relief. Your heart flows down, your muscles relax. What you do not realize is that you just gave your brain the single most dangerous reward signal in human psychology. In a landmark series of behavioral neuroscience studies popularized by researchers like Susan Manecker and Richard Zinbach, scientists demonstrated how avoidance acts as the ultimate engine of fear maintenance. In neuroscience, this is governed by negative reinforcement. When you avoid a harmless trigger, your amygdala does not learn that the situation was safe. Your amygdala learns that you only survived because you ran away. Let that sink in. Every time you dodge a harmless trigger, your brain marks that avoidance as a heroic, life-saving victory. Your subconscious records a simple equation. I felt panic, I backed out of the room, and I did not perish. Therefore, the room was lethal, and running away is what saved my life. You think you are keeping yourself comfortable, but you are literally training your neural circuits to be more terrified next time. The neural groove deepens. The synapses connecting that harmless stimulus to the amygdala's fear center undergo long-term potentiation. They literally grow stronger, faster, and more robust. What started as a faint whisper of unease becomes a rigid, automated panic response. Before you understand this mechanism, you view your fear as an invading enemy. You feel a sudden spike of anxiety and you assume there is something fundamentally broken inside you, or that the environment around you is genuinely dangerous. After you understand this mechanism, you realize that your brain is simply a hyper-reactive prediction engine that has been handed faulty safety data. You are not dealing with real danger, you are dealing with a biological misattribution of safety. So how do you systematically dismantle this circuit? How do you take a neural pathway that has been reinforced through years of avoidance and rewrite the underlying code? You do not do it by arguing with your thoughts, and you certainly do not do it by forcing yourself to calm down through sheer willpower. You do it by speaking the biological language of the brain through 3 specific, concrete mechanisms. First, exploit the inhibitory learning model through expectancy violation. For decades, people believed that overcoming fear meant erasing the old fear memory. Modern neuroscience shows that you almost never completely erase a fear memory. Instead, you build a brand new, dominant inhibitory pathway that overrides the old alarm. The most powerful way to build that pathway is not just gradual exposure, but deliberate expectancy violation. Before you face a situation that triggers that irrational surge, ask yourself one brutally precise question. What is the exact catastrophic prediction my brain is making right now? Is it that you will faint, that you will lose control, that the spider will jump onto your face? Write down the exact prediction. Then, put yourself in contact with the trigger just long enough to let the timeline disprove the prediction. When the predicted disaster fails to materialize, your prefrontal cortex sends an unexpected error signal down to your amygdala. That prediction error is the exact biological spark required to lay down new inhibitory neurons. Second, engage in precise affect labeling to activate prefrontal braking. When the low road fires, your emotional limbic system is operating without cortical oversight. In pioneering fMRI studies conducted by Matthew Lieberman at the University of California, Los Angeles, neuroscientists discovered something astonishing. When individuals who are experiencing intense emotional arousal simply put their exact physiological sensations into precise, objective words, activity in the amygdala drops dramatically, while activity in the right ventrolateral prefrontal cortex surges. Do not say, "I am panicking and this is terrible." Instead, narrate the raw biology like a detached lab researcher. My heart rate is elevated. My palms are exhibiting a galvanic skin response. My breathing has shortened. The moment you convert a vague visceral terror into precise linguistic data, you force your thinking cortex online. You manually deploy the neurobiological brakes on your own fear circuit. Third, Eliminate subtle, covert safety behaviors. This is where almost everyone fails. When people try to face their fears, they often carry invisible crutches. They hold their breath, they grip their steering wheel with white knuckles, they constantly check their smartwatch for their heart rate, or they mentally chant affirmations to distract themselves. To your amygdala, a covert safety behavior is still an escape. Your brain tells itself, "We only survived that elevator ride because we gripped our keys so hard our knuckles turned white." To truly reset the threshold, you must drop the safety behaviors entirely. Drop your shoulders, unclench your jaw, exhale slowly through your mouth, letting your belly expand. By forcing your physical musculature to mirror absolute safety while the alarm is sounding, you send a bottom-up somatic signal to the brainstem that the alarm is entirely invalid. When you step back and look at your own history through this lens, your entire relationship with your own nervous system transforms. You stop treating your anxiety as an identity. You realize that your racing heart, that sudden tightness in your chest, and that irrational urge to turn around and flee are not evidence of weakness. They are simply the echoes of an ancient, overprotective biological guardian running an outdated program. Your brain is not trying to torture you. It is desperately trying to keep you breathing using blueprints written millions of years ago. Now that you understand that your fear grows solely on the fuel of avoidance, look back at your own life right now. What is the one harmless thing that triggered your alarm today? Drop your answer in 5 words or less below. Bookmark this exact breakdown by hitting that like button so you can instantly re-anchor your prefrontal cortex the next time your amygdala misfires on you. This is only the surface of the unconscious programming dictating your daily choices. There is another hidden neurochemical loop, one running right beneath your everyday habits that we are analyzing in the lab right now. Make sure you subscribe immediately so you do not miss that revelation the second it drops.